So now we're doing FreeCodeCamp Legacy Python for everybody, web services, XML Schema. All right. So let's make sure we have our notes out. Let's scroll all the way to the bottom, right there, and let's get to it.
So now we're going to talk a little bit about XML Schema. XML Schema is a language.
All right, let's type that down. XML Schema. Schema. Who knew? I thought it was schema. XML Schema. Schema. So it's hold on. This is gonna drive me bananas. All right, there we go. So it's describing a contract as to what is acceptable XML. What? We'll find out what that means right now.
That allows you to decide on whether or not a particular XML document meets a contract, an arrangement. So you have two pieces of software exchanging data using XML. And what if one of them, if they're all working, nobody really worries too much about it. But if all of a sudden one breaks, you change one side and the other one breaks, whose fault was it, right? Was it the...
I don't know. Who cares whose fault it was? Let's just get it back to work. Working order. How about that? Let's type this stuff down before we go deeper into this. XML schema. XML. I'll just type that down. All right. So description of the legal format of an XML document. Okay. What is this next part? Expressed in terms of constraints on the structure and content of documents. What? I don't know what that is. That's why we're learning, right? Now, what else? It's often used to specify a contract between systems. Okay. My system. Let's drop this down, actually. Right here. How about that? My system will only accept XML that conforms to this particular schema. That sounds pretty, what's the word? Pretty limiting, I guess. All right, so let's do that. But I guess sometimes limits are important. So let's do this next one. If a particular piece of XML meets, the specification of the, is it capitalized? I'm not capitalizing that anymore. Schema. We don't just make up any rules we want when it comes to capitalization. It is said to validate. Specification. How about that? All right, so there's that. What does all this mean? I don't know. This is the first time I've seen it, so let's listen to him talk about it.
The side that got changed or the other side, and so you could argue. So what you like to do is before it meets a contract, an arrangement. So you have two pieces of software exchanging data using XML, and what if one of them, if they're all working, nobody really worries too much about it. But if all of a sudden one breaks, you change one side and the other one breaks, whose fault was it, right? Was it the side that got changed or the other side? And so you could argue. So what you like to do is, before you set up these arrangements between these applications, set up a contract. In a way, they're kind of like the RFCs are, except that their scope is between pairs of applications.
What's an RFC? Right? An RFC, what the hell is that? This is the first time we've run into something like this, and it's not going to be the last. What's an RFC? Okay, we'll look it up later. How long is this video? 14 minutes. This is gonna be
and so it itself is XML, and it basically, what we do is we take an XML document and an XML schema contract, and then we either say that's good or that is bad, and that's called validation. A piece of software that validates XML when given a schema is called a validator.
Okay. So what? Okay. What?
And so an XML document, here we have our little XML document, we're passing it to the validator, and then we have a schema contract, which is itself XML. It's kind of a particular kind of XML, that XS : complex type. That's just a tag. Colon is a legitimate character for the name of a tag. Name equals person, that's just an attribute. And so XML schema is a particular format of XML that renders an opinion about what XML is supposed to look like. So there's a number of different XML schema is a particular.
What the? All right. All right. So let's just write this down. Let's write this down and all this, and then we'll figure that out the next part after that. All right. So let's do that. So we've got XML document, and so let's make this little example. We'll have one of these person. All right, so there's that one. We'll say person in here, just like in person. Just like in HTML, we're going to make the containers like that, and then we'll drop them down how we need to, the way we need to. All right, so now we've got inside of here, we've got last name. Okay, and close last name, and we'll put in here last name, whatever. All right, we've got age under that. Oops. Come on now. What? Okay, age. Close age. It doesn't have to be anything, right? It can be any string number. There we go. All right, date born. Oh, this must be his kid. All right. Way to dox your kids, right? Hold on. Here we go. And then we'll say date born, close date born. And we'll say date. There we go. And then, oh God. So annoying. Whatever. This is learning, right? XML Schema document. It's contract. Oh, man. All right. I don't want to do this. You ever gotten to that point? Okay. XS complex. That's not how you spell it. Complex type name equals person. All right. And then we're going to close XS complex type. XS complex type. All right. Bring this down. Tab it over. And then inside of here, we're going to have the sequence. So we'll do, what is this? Close sequence? Close XS. All right. And then we'll have this inside of here. And then inside of this, we're going to put some more stuff. All right. And then right here, we're going to say XS element name equals last name. So XS element name equals last name. Type equals XS string. And self-closing, all right? So we don't even need this part. All right, so let's take this, copy it, drop off 2 times. Age here. That's not how we do it on text editor or whatever this thing's called, Notepad. Age here, and then right under that, we're going to do date born. Date born. Access date. This one's an integer. So let's change this to a number. Date. I don't know what day that would be at 51 years old. I don't know. 2, 3, 4, 5. There we go. There's a date. Maybe. What does it look like over here? Oh, yeah. Let's say 200-203 25. There we go. There's a date. So yeah, date format. So that's date format basically. And then so that's it. That's and then this will validate something. I don't know how that works. So let's go.
Is itself XML. It's kind of a particular kind of XML, that XS colon complex type. That's just a tag. Colon is a legitimate XML schema is about what XML is supposed to look like. So there's a number of.
Oh, one of those days. I got a case of the Mondays on Tuesday. Oh. 1 minute 34 seconds and 14 minutes on the video. My goodness, I hate doing this. Some days I just don't like it. All right, so let's come down here. Many XML schema languages. Many XML schema languages. Okay. Document type definition. All right, DTD. Okay. And then there's a website under there for a Wikipedia page. So we'll just say Wikipedia. All right. I mean, you just look it up, right? we're not even going to put that Wikipedia thing. Standard generalized markup language. And we've got some ISO 88, 79, 1986, SGML. Okay. Is that from a book? That looks like a book, like one of those library things. All right, so XML Schema form W3C. And then this XSD. This is another Wikipedia page. Okay.
Different XML schema languages. The one we're going to look at is one that's kind of came a little bit later. That's very common, called XSD, which is the World Wide Web Consortium's schema specification.
Right.
Often you'll find files that have suffixes of .xsd that actually contain the XML, just like we're going to show you.
Okay. Love it. Let's go over this slide that was basically ignored. All right. XSD, XML Schema, W3C spec, W3C spec, World Wide Web Consortium spec. We will focus on the World Wide Web Consortium W3C version. Okay. It is often called W3C schema because schema is considered generic. Okay. So, okay, I don't care. I mean, whatever. More commonly, it is called XSD because the file names end in .xsd. Okay. So that explains that riddle. Let's go.
.xsd that actually contain SD, which is the World Wide Web Consortium's schema specification. Often you'll find files that have suffixes of .xsd that actually contain the XML, just like we're going to show you. So if you recall, there are simple elements.
Here we go. XSD structure. Okay, we can reuse this, and we can reuse this. Great. So let's do that. So let's do that here. XSD structure. All right. So let's figure out how to make this something. Check it. Let's grab this and this. All right. Drop it, bring it down here. Drop it like that. Let's get rid of this. Could have done that a little more cool, but a little more smoothly, but it is what it is, right? Where's the other part? All right, there's structure. Let's go get contract. Hold on, which part is this? All right, let's get this part. And throw it right here. Okay. So now let's mark this up notes style. All right. So we've got elements are the browns or the oranges, whatever. And then we've got greens and we've got yellows. All right. So let's mark these up. How should we do this? How should we do this? Let's do this. Hey, what's going on, man? Let's do this. Let's say XS element, XS element. Is that even an XS element? Okay. XS element, XS complex type. Man, I don't like this at all. Can we do this? Nope. All right. Let's try this. XSCT. Complex type. All right. Doesn't look the best, but it doesn't look the worst either. And then we've got XSE, 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 then XSCT. Okay. And then we'll put over here XSCT equals XS complex type. All right, put right here XSE equals XS element. Then we'll put right here XSS equals XS sequence. Okay. Hopefully we'll remember that later, but if not, no big deal. All right, so here we got that, and then right here we've got XS CT. Let's do this. All right, we've got one here, we've got one here. We've got XS sequence here. All right, and then we've got this stuff in the middle. So not confusing, right? Anyway, whatever, let's go.
Which have text children, and then they're complex elements where other nodes are children of other nodes. And so we can say this. And so here we have a little bit of XML, and the XML schema that makes sense with that. So
makes sense. That's rich. Anyway, I don't know. I can't really pay attention right now. Actually, you know what? I think I'm going to cut this one short, and then we'll come back and edit it up. We'll come back and do the rest later. Oh my God. 2 minutes, 13 seconds. 24 minutes on the video so far. Oh my God. This is one of those days. Whatever. We'll get back to it later. And there we go. So I'll see you in a little bit. All right. So here we are back at it. Let's finish this up. Did we already type all this? I think we did. Let's make sure. Yeah, we did our little stupid code thing. Let's go.
What we're saying is the outer tag of this legitimate XML is supposed to be a complex tag with a name of person. And so there we go. That looks good. Good, good. Then there is a sequence, and then there is a simple element, a name of last name, looks good. and it's a string. That looks good. Another tag that's of a named age that's of type integer. That's good. And then a thing that's called date born, and then there it looks like a date. So we check all these things, and we can basically say, yup, you know, that is a good XML document according to this schema. And
okay, let's look at that, what we wrote down. All right, age 51. Okay, so that's a number. Okay, so that was what I was checking on. Let's see, hear the rest of it.
You don't have to write this generally, but there is software that reads these two things and comes back with a true or a false, and might even have some detail as to what went wrong with this particular schema. Here's some more that you can do.
All right, let's look at this. XSD constraints. What was XSD? It didn't say. What is this? What? All right, let's listen to him talk about it.
Do with a schema, we can do things like, you know, have a complex type. We have a sequence. Here we have a string full name and a string child name, but we have this min occurs and max occurs. So min occurs is the minimum number of times it can occur, and maximum is the maximum. So min occurs equals 1, max occurs equals 1 means it's required. And so this is required, and we don't have two of them. Two of them would be an error. One of them is fine, so that's good. Here, the child name is min occurs 0, max occurs 10. So we have 4 here, and so that's good too. And so that is another kind of XML schema constraint that you can have. Here's a few other data types that we can do.
Hold on. So, min occurs, max occurs. These are the little, pardon me. These are the little attributes inside of this stuff. All right. I guess that's what we're calling them, as constraints. And so min occurs, max occurs. This only can occur one time in the blue. The element name, full name. So this full name can only occur once. Element name, child name, type string can occur 0 to 10 times. And so 4 is between 0 and 10. So that's cool. Okay, let's go to the next one.
There's a few other data types.
All right, so customer type equals XS string. Customer. That's the customer. Start equals date. That's the date. Start equals date time. So this is date time right here. I don't know what this Z is for, but we'll find out probably. And then decimal. Yeah. Integer. Yeah. Okay.
Types that we can do. We've done the string. We've done the date. The date looks like this. Dates are 4-digit year, 2-digit month, 2-digit day with dashes. Now there's lots of different ways to represent dates, but the nice thing about this, and you have to put the zeros in, so 09 for September. It means that these are sortable as strings, so that if you do all your dates this way, they're sortable as strings. So you could argue what is prettier, but for computers we don't worry about that. We're arguing about what's the most functional. Sure. And then the date time is that same date format with zeros, followed by the letter T, and then followed by hours, minutes, seconds, 0 filled, right? So 9 o'clock is 09, and then the time zone, which we'll talk about a second in the next slide. You can have decimal numbers, and you can have integer numbers as well.
Okay, so that Z is a time zone filler. It is common to represent time in, I guess that's why it's white, in UTC or Greenwich Mean Time, given that servers are often scattered around the world. It makes sense. So yeah, that's what's going on with this white area, but we'll see how we actually do it. Let's go.
And so we are able to sort of render an opinion as to what is good and what is bad in the resulting XML. So dates are kind of interesting.
All right.
There's, again, we have lots of different formats of dates, 9.
Let's write this down at least. ISO, let's do that. So ISO 8601 date time. What else did it say? Date time format. Okay. It's an example, so let's do it like this. We've got 202 05 30 T 09 30 10 Z. All right. So year, month, day, obviously. So let's do this. Do this. And let's say year, month, day. Then we've got another one here. Oops. All right, and then this one will say, nope, that's not where it is. Time of day. And then Z, time zone. Typically specified in UTC, Greenwich Mean Time, rather than local time. Okay, so there we go. Let's go.
There's, again, we have lots of different formats of dates, 9, 10, 9/10/2002, right? That's a format of a date, but that's one. There's another format of the date, which is 12 December 20, whatever.
True.
And so this is how people show dates. Computers don't want to have all those different dates and don't want to figure those out. They have libraries that produce dates and make them look pretty and for particular locales, but computers really want dates that work best for them. So we just say, okay, we're going to have this year, month, day, time, and then zero fill, hours, minutes, seconds, HMS, and then time zone. Now, computers even prefer a time zone. I don't know if you've used something like your Google Calendar and you take a flight or take a train trip and you end up in a different time zone, everything switches. And that's because Google Calendar is not really storing the time zone that not storing the dates relative in your current time zone. It's storing them in what we call universal time or Greenwich Mean Time. Zulu time is another word for that. And Z means this time that is the time in London, England, Greenwich Mean Time. And so the thing is that means if this data moves between time zones or crosses the international date line or standard daylight savings time or anything like that, none of that changes. And so we have this internal date and time that's very common in situations where computers are exchanging data that then gets shown with a time zone, converted to the time zone or the local format. That's the right way to do that. And there's a standard for how dates and times are supposed to look. So here's another little example of some stuff. Let's see what we got. Now, if you see this little question mark XML, that's not a problem. That just is a way of sort of putting a header on the whole document that says it's an XML document, telling it that it's a UTF-8 document. And that's not really a tag. That's sort of like a marker on the file, so that you can put that there, but it doesn't harm the XML. The outer tag is this tag right here, XS:\schema. And then what else we got? We got an address. We've got a string. We've seen all those. Here we have country, and we're going to have a restriction that basically says this is a simple string, but we're going to make it so that you have to list one of these 4 as the country code. And so here we are down here, and that's UK, and that's UK, and so that is valid XML.
What?
Another couple of examples here. Valid.
Okay. So this is the XML, and this is whatever's the HTML? I don't know. Let's go.
Valid XML. Another couple of examples here. let's see, string. Max occurs unbounded. That means infinite number. There's no limit on the number. You can do that. Min occurs of 0. Excess positive integer. We've seen integer, but you can also say it's got to be a positive integer. Decimal, we've seen that. And then use equals required is just another statement that you can make. I'm not trying to get you to the point where you can do XML schema. Just get you a sense of the kinds of statements that we can speak about when we're talking about what is and is not legitimate XML.
Okay.
So let's talk a little bit about how we might talk XML inside Python. And so,
yes,
like most things that are in this extended part of Python, we have to import something. And so this is the name of a library, XML eTree element tree. And then as ET, this ends up being a shortcut. So we don't have to type these long things. And so ET is the same as typing that. It's almost like a macro. Now, normally this XML is going to come somewhere from the network, but I'm just going to put this in a string. I'm using a triple quoted string. And so that means that this triple quoted string starts here and ends here. And all these new lines that are here are actually part of the string. So this is kind of like I opened a file and read the whole thing in. But just to keep this totally self-contained, I'm putting it in a string. So the XML would come from some server on the other side of the network. We would get this XML. So that's how it would normally work, okay? So this is the XML right there. And we parse a string of data, and we call ET from string. So we're passing in the less thans, the new lines, the greater thans, all of this stuff, we're passing it in. And this could have syntax errors in it. So this might blow up if this had a syntax error, like we forgot the little slash or something, there was a syntax error. But this doesn't have a syntax error. So then what we do is we get back an object. I just happen to call it tree because it kind of is like that tree version of the XML. That is an object that we can then query to pull data out of it. So we say tree.find and look for a tag name. So that finds the tag name is this. It's everything. It's the tag and the text. If we want the text, we add .text, and then that .text, that actually refines it to only the word Chuck. And similarly, if we do tree.find email, that tree.find email, that finds the email tag, which is this tag. It has a child attribute, and you can get any of the attributes. You say .get. There's only one text child, but there are many attribute children, and so you have to tell it which one you want. And so this bit right here, all of that will resolve down to that string yes. That's what you're going to get there, yes. And so you kind of build up these little finds and call methods. This is not clearly a full introduction to element tree, but you get the idea that you sort of dive down in with these methods that call methods to get little pieces out and parse all of that.
Oh.
Here is a different example. In this one, again, we're using triple quoted string. We always have a single tag on the outside, and then I have a complex type of users, and in it there are two user objects. So this is kind of like a list, right? So this is more than one of these things.
All right. How do we know it's complex type? Do we need to know it's complex type? All right, here's complex type. Where does that say that over here? All right. Access. Where's the accesses over here? Huh? What? Am I missing something? Did this change? Is this something different? Where'd all those XS's go? All right,
so this user can occur more than one time. And again, we take this, we pass that into from string and get back an object that represents the name stuff. Does not necessarily have to be the same as this outer tag. Just a variable. This could just as be easily as X if I wanted. And so now what I'm going to say is, hey stuff, I want to find the tag, the path, users/user. I want to find all tags that match users/user. So that's going to give me a list of 2 tags, 1 tag, 2 tags in a list. Tag, tag. Oops. So 2 tags. Now I can print out how many I get. That'll be 2 in this case because I got 2 tags. And then I can actually iterate through the list. All right, so I can iterate through the list. So this item is going to iterate first to this tag, and that tag, now it's like in the previous example, we can look for the name tag within there and pull the text out. So we pull that text out, find the name tag, and then within that find the text. And we can find the ID tag and pull the text of that out. So that pulls out this 001, and I've scribbled too much. And then we can item, which is, this is item, is that whole tag, dot get X. So that gets the attribute, that gets the 2. That 2 comes down here. Okay, and then item goes to the next one, because item is looping through, so item iterates down to that one and pulls out the name.text, the ID.text, and the attribute.x, and pulls all those pieces out. So this is the basic pattern. You saw one where you're tearing into a single thing, and here you're tearing into something that is expected to occur more than one time. And so that's a quick summary of how you talk to XML in Python.
Wow.
Up next, we're going to talk about the other serialization format, JavaScript Object Notation.
JSON. All right, well, whatever. That went in one ear and out the other for me. But whatever. Honestly, I'm not really too sure what's going on here. I feel like there's something missing. Because look, here's all these XS's, and then we go forward. Here's some more XS's, and then we go forward, and they're gone. So it must have been changed here, right?
The kinds of statements that we can speak about when we're talking about what is and is not legitimate XML. So let's talk a little bit about how we might talk XML inside Python. And so, like most...
Okay, so this is... so this is a Python... pardon me. So this is a Python file? Which part's the Python, though? Is it all... No, yeah, import. So we're importing this. We're going to type this crap first. And then, what is this junk?
Things that are in this extended...
Anyway, whatever. We'll go over it right now.
part of Python, we have to import something. And so this is the name of a library, XML eTree element tree. And then as ET, this ends up being a shortcut. So we...
All right, what? All right, so data equals all this. That's what this triple quote's talking about? Okay. What's the triple quote for? Is that so we can put it on new lines?
We don't have to type these long things. And so ET is the same as typing that. It's almost like a macro. Now, normally this XML is going to come somewhere from the network, but I'm just going to put this in a string. I'm using a triple quoted string. And so that means that this triple quoted string starts here and ends here. And all these new lines that are here are actually part of the string. So this is kind of like I opened a file and read the whole thing in.
Oh, what the open the file and read the whole thing in? What does that even mean, man? All right, so here's some data. Tree, ET from string data. What?
But just to keep this totally self-contained, I'm putting it in a string. So the XML would come from some server on the other side of the network. We would get this XML. So that's how it would normally work, okay?
What? So this is coming from the server? How did we get it from the server? Anyway, I don't know what's going on here. This is one of those parts where a nerd starts yapping about their favorite thing and forgets that yapping isn't for the yapper. Yapping is for the person getting yapped at. Okay? If you're just yapping to yap, then yap in your own head. You know what I'm saying? Whatever. So there's that. Let's look at this. What is XSD? Extendable Situational Driver? Or the W3 Schema specification for HTML? It's not this one. Extensible situation. I don't remember that being a word, a phrase. Let's check it for A. Look at the and submit it. All right, so this is the crappiest video, one of the crappiest videos I've done in a while, but it is what it is. Can't do what I can only do what I can do. That being said, now we're on to web services JSON, whatever you want to say, and we'll see you next time.